Hey, I'm Kiara and I study international politics at Leiden University.
Hey, I'm Holly and I study international studies at Leiden University.
Hello, I'm Maarten and I study mechanical engineering at TU Delft.
Hello, I'm Benjamin. I study management of international social challenges and I study at Erasmus.
Let us take you through our time for the last 3 months in Vietnam. Hanoi, one of the world's most polluted cities, faces severe air pollution from open fire burning, which contributes to global warming and damages respiratory health locally and globally. Founded in 2020 and based in Hanoi, EBG Science and Technology Company Limited develops biomass gasification equipment and clean energy solutions. Its mission is to combat climate change, enhance business competitiveness, and provide disadvantaged and underprivileged communities with access to affordable clean energy. EBG's beneficiaries are small firms and households in northern Vietnam, particularly those processing green and black tea or relying on open fire. By offering affordable and sustainable solutions for cooking, agricultural processing, and heating, EBG embodies frugal principles such as resource efficiency, simplicity, sustainability, added social value, and accessibility. Over the past 3 months, we have supported EBG by enhancing public outreach, improving gasifier efficiency, and assisting in securing funding for the project.
This project exemplifies frugal innovation by offering practical, cost-effective solutions tailored to local needs. EBG's biomass gasifiers use agricultural residues like rice husks, corn cobs, and wood chips as sustainable alternatives to firewood and coal. By repurposing waste materials, this approach reduces reliance on costly, harmful fuels while lowering energy expenses for households and small businesses. The shift from firewood mitigates deforestation, reduces greenhouse gas emissions, and improves air quality. It also significantly enhances respiratory health by reducing exposure to harmful smoke for workers, women in households, and children. The gasifier's affordable, simple design ensures accessibility and adds social value, promoting equitable clean energy access for disadvantaged communities. This project addresses global issues like climate change and air pollution while supporting local economic growth and tackling preventable health risks, showcasing how frugal innovation can drive transformative change at both the macro and micro level. This project encountered multiple challenges. Financially, the company is dealing with the end of a crucial 4-year EU grant, which has been its primary source of funding. Socially, barriers to the adoption of biomass gasifiers persist, largely due to limited awareness of their economic health and environmental benefits. And additionally, current biomass gasifiers face design challenges, particularly regarding efficiency. In 2021, EBG and CCS secured the BEST or BEST grant, a major EU-funded project addressing sustainable energy, agri-food processing, and waste management in rural Vietnam. This grant tackled critical challenges like inefficient coal and wood burning by promoting frugal, low-cost biomass gasification technology, creating cleaner, affordable energy solutions. With the grant ending, EBG urgently needed external funding. After thorough research, we identified the IKI or EKI grant as a fitting option, given its focus on climate change mitigation and biodiversity conservation. Additionally, we also applied to the Livability Challenge, Asia's largest sustainable innovation competition, not only to win, but to also boost EBG's visibility as a strong player in sustainable innovation.
To better understand these issues, we traveled to provinces in northern Vietnam, including Dien Bai, Bac Can, Thanh Nguyen, Ninh Binh, and Ha Nam. We visited households and small factories processing green and black tea, as well as the Women's Union in Bac Can, where the community had recently adopted biomass gasifier cook stoves. Through interviews with small business owners, we discovered that the initial cost of the gasifier was a significant barrier for many. However, those who had transitioned reported substantial savings, up to 80% on fuel costs and lower labor costs. Sharing these success stories with traditional users became a key part of our work and a strong recommendation of ours for future marketing. Another major challenge was the lack of awareness about how biomass gasification reduces climate impact and directly improves people's health. To address this, we developed a public outreach strategy focusing on 2 key messages: the monetary savings and the environmental and health benefits of transitioning to biomass gasification. We found that emphasizing the long-term economic advantages motivated people to engage in the broader issue of climate change. Our outreach strategy is a frugal solution leveraging Facebook, a platform already widely used in rural Vietnam. This ensured accessibility without requiring audience to adapt to new tools. By tailoring our approach to the needs of our beneficiaries, we address these challenges cost-effectively while promoting the adoption of this sustainable technology.
In terms of the engineering challenges, we've had 4 major challenges, which I've resolved mainly by doing computational fluid dynamics calculations and building an efficiency model in Python. The first big problem is the huge smoke production in the beginning of the startup phase of the biomass gasifier. To combat this, I've done lots of calculations with the flow simulation to resolve certain design aspects to make sure that the whole starting process gets more air and will be resolved quicker. Another thing that we've been implementing is using baffles to create more turbulence at certain points to ensure that there's more contact between the air and the biomass, so that the startup time and the system efficiency can be improved. The second big challenge is cost, especially for the coke stove version where the previously mentioned business model isn't available. We have to bring down the production cost a lot so everyone can afford it. We've mainly been doing that by introducing certain design changes which will have a small loss in performance but a big gain in reduction in production cost. The third big design challenge is relatively low efficiency. A biomass gasification process always has a very low efficiency, but to make sure we can choose the right model, we have made a Python script in which we can calculate the proper system efficiency. By having this script, we can compare different models with each other. Lastly, a lot of engineers didn't have a very good understanding how the biomass gasifier exactly worked. To enhance this, we have done lots of technical testing. To create an accurate model of the biomass gasifier, we made a measuring setup using pitot tubes, which was a big challenge because pitot tubes generally don't work very well at high temperatures. Apart from that, we've also been using lots of infrared measurements to calculate the heat on the outside of the biomass gasifier to calculate the heat losses. All of this testing was very important to implement in the Python code to make sure that we can calculate the total system efficiency of different models. All those different models then could be compared with each other. Lastly, we've tested using baffles to create turbulence in certain areas where we want to create turbulence so that we get a higher quality biogas.
Our work with EBG highlighted the importance of social media, particularly Facebook, for outreach in rural Vietnam. To address the lack of accessible information, we created bilingual templates and plans to engage both local and international audiences. We also recognized the significance of grant applications for financial stability and visibility, positioning EBG as a leader in sustainable energy. Strong customer relationships have been key to EBG's success, fostering trust and community engagement. However, engineering processes could benefit from more advanced simulation techniques like CFD testing to improve gasifier efficiency. Additionally, we believe that the untapped economic potential of biomass fuel offers opportunities for new frugal innovations. We recommend that EBG continues bilingual outreach, maintains Facebook as one of their key marketing platforms, strengthens grant application processes, and explores further frugal innovations to maximize the value and expand the impact of biomass gasification.